All right, so Algebra 1, quick review, summation of sequences. So you have to remember two different main types of sequences, an arithmetic sequence and a geometric. And you got to remember the formula. You're not going to be able to do summation without the formula unless you write out every term. So the sum of the terms, that's the S of n right here, equals n. That's how many terms you're going to have. A sub 1 is the first term. A sub n is the last term, divide by 2. All right, that's the summation formula. Let me show you how it works. So you're given a problem like this. There's the summation symbol, right? The I tells you where to start with the first term, with I being 1, and we're going to go 50 terms. Okay, and here's the rule on how to figure out each term. 7 minus 2i. All right, so we already know n is 50. So as I go to run my formula here, I already know that n is 50. However, I do need a sub 1 and I need a sub n. 2, of course, is a 2. So how am I going to get a sub 1? Well, it's pretty easy. I use the rule and I put it in 1 for the I. So 7 minus 2 is 5. A sub 1 is a 5. Okay, so that's 5 there. Now, how do I get a sub 50? The same way I got a sub 1. A sub 50, 7 minus 2 times 50. All right, 2 times 50 is 100, so that's negative 107. This is negative 93. This is a negative 93. All right, so from here on out, I can just simply run my formula. Okay, so 5 and a negative 93, what is that? A negative 88. And 50 divided by 2 is 25. So 25 times a negative 88, and I get negative 2,220. Negative 2,200. I'm sorry, negative 2,200. Better be able to read my calculator correctly. Okay, so what does that mean? Add up the first term plus the second plus the third plus the fourth plus the fifth plus the sixth all the way through the 50th term, and you get negative 2,200. All right, so, and by the way, remember, an arithmetic sequence has a common difference each term. So if the first term was 5, then the next term, the second term, ends up being a 3. A 3, and the common difference is 2. All right, quick review, so I really can't get into more of that. Watch the full video. All right, what's the formula for a geometric sequence? A sub 1 times 1 minus r to the n divided by 1 minus r. Now, you remember what r is. R is the common ratio, and that's what makes a sequence a geometric sequence. There is a common ratio. All right, so again, we have summation formation. The symbol here, I again is 1, and we're going through the 8th term. So we're going to add up or sum the first 8 terms. Okay, so as I begin to work the formula, I'll see what I have and what I'll need. All right, right off the bat, I don't have a sub 1. So let's go ahead and find that. A sub 1. Again, I'm going to take what I have, 5 times 2 to the n, and the n is going to be a 1. And so the a sub 1 is going to be a 10. Okay, first term is 10. Great. The 1 is a 1. Got the minus sign. Now, do you know what the common ratio is? Well, if you remember the format, it's the 2. What if you forget that? You don't realize it's the 2. Well, the other way to do it is find the second term. 5 times 2 squared. 2 squared is 4 times 5 is 20. You might say, well, how does that get me the common ratio? If you always take a term, second, divide it by the previous, you'll get the common ratio, and you can see it's 2. So again, the easier way is to know that it's the base, but if not, find the second term and then subtract them out. Okay, so our common ratio is 2. We're going to the 8th term, so that's 2 to the 8th. We're going to divide that by 1 minus, and the common ratio is 2. Okay, so you got to punch this in your calculator. I'm going to do 2 to the 8th, and I'm going to get 256. So 1 minus, that's a negative 256. So that's a negative 255 times 10, and then divide it by negative 1 is going to make it a positive, and I end up with 2,200. 550. That's the first 8 terms of a geometric sequence. You say, how did it get up there so fast? We only did 8 terms. Remember, a geometric sequence is an exponential curve, and so it goes up more quickly. All right, that's supposed to be a quick review, but that's the way to do both an arithmetic and geometric sequence, right? So that's the way to do both.